this month's Footsteps to Mars Hangout. My name is Tony Darnell, and I run DeepAstronomy.com. And you are watching the monthly series that we put out each of the first Friday of every month, where we explore topics, as our name suggests, on getting us to Mars. And this week, we're going to be talking about the human missions to Mars, when and how. And if you'll notice on the little poster that I sent out, the little graphic, it had a little 1 in parentheses. This is going to be the first of a couple of them, I think, and these are some that have been set up by my co-host, Dr. Harley Thronson. Hi, Harley. How are you doing?
Good afternoon, or morning, or evening, wherever you guys are.
Wherever you are. That was you, wasn't it? With that, I told you. With that YouTube.
How quickly was it handled?
You're very good. Also joining me.
The source of every strange background noise that we've had ever since we began these. So.
That's right. Dr. Harley Thronson, he's an astrophysicist at Goddard Space Flight Center who helps us coordinate all of these hangouts and does all the legwork that gets these experts and our guests to you. So welcome, Harley. It's good to see you again.
Good to see you all.
And also joining me is my good friend, Dr. Alberto Conti. He is the Northrop Grumman Aerospace innovation scientist and extraordinaire, and it looks like he's back in his office too. Hi, Alberto.
I'm at home actually.
Oh, you're at home. Okay, well you gotta.
Here's the clock. Good to see you, Tony.
Yeah, it's good to see you too. Welcome back. I'm glad you're here. So this week we're going to be talking, as I said, with some experts from JPL and Aerojet Rocketdyne. But before I introduce them, I would like to let you guys know how you can leave questions and comments for us. And last week we had a bit of an issue, or last Hangout we had a bit of an issue with the chat window. So the best way for you to communicate with us on the Hangout and leave questions for our guests, and I will read them out, will be the easiest way will be on Twitter. If you use this Footsteps to Mars hashtag, I've got that up on TweetDeck and I'm looking at it scroll by. So that would be the easiest way to get guests out there, or get questions to our guests or comments to that you'd like to make, and we would welcome you to do that. But I've also set up an email address for these Hangouts, hangouts@deepastronomy.com. So just email your questions. If you don't have Twitter, you almost certainly have email. So I'll be checking that as well, hangouts@deepastronomy.com, and I'll ask your questions as they come up. So today, getting to Mars. Lots of talk about doing this. We've got a lot. NASA's trying to do it. The plan is to do things by the mid-2030s, I think, was the last timeline that NASA has talked about. There has been recently a Humans to Mars Summit that was held last month where they talked about all of these things, and I watched a lot of that. We're going to talk about some of the topics that were raised there during that summit as well. And so we've got, our guest today, let me just go ahead and introduce. I have Hoppy Price. He is the, let me pull up my thing here. He is the Robotic Mars Program Chief Engineer at JPL. Hi, Hoppy. Welcome.
Hi.
Hi. It's good to have you on our Hangout. Are you there?
I'm here.
Okay, good.
Can you hear me?
Good to have you. Okay. I just want to make sure you're there. Also joining me is Joe Cassady. He's Executive Director and Deputy for Space Programs at Aerojet Rocketdyne in the Washington operations, so I guess that means up in Washington, D.C., and he helps build a lot of the rockets and space vehicles that are going to get us to Mars. Hi, Joe. Welcome.
Hi. Thanks, Tony.
Thank you for taking time out. Now, I know you're on vacation, but I appreciate you're taking some time out to talk with us about getting to Mars, so I appreciate it. Okay, so let's go ahead and get started. So I guess I want to start with, so our topic, or our title said when and how for human missions to Mars. I want to start with when. And the timeline to me has always been a little bit fuzzy. I mean, I've watched all the things, I've read all the press releases, I've watched the things that NASA puts out, and I read the articles that everyone does. And there's a lot of confusion about this timeline of getting to Mars. And so what I would like to ask you guys, and Harley and Alberto, you comment on it as well. But what are the steps that are being taken by NASA and JPL for getting us to Mars? I mean, what's the biggest overriding goal, or the programs that are being in place here for these things? And just take anybody who feels like responding.
Okay. Joe, you want to go? Joe, go ahead.
You go first.
Okay.
Right.
So, NASA is focused on trying to build the vehicles to go to Mars and to test them out in lunar orbit, and the focus really is on sending humans to Mars orbit and to Phobos in 2033. And 2033 is a very nice opportunity, although we could go at any of the 2-year opportunities that we have to go to Mars. So there's the SLS, there's the Orion that's being built, and then NASA is starting to focus on building the deep space habitat where the crew would live on the way to Mars and back, and there are industry contracts out on that now. Another big item is advanced propulsion, ion drive, solar electric propulsion, and there are contracts out to industry for this ion drive tug, which would be used to send cargo out to Mars, and that's right now it's part of the ARM program to develop that SEP tug. And really the other items that you need are chemical propulsion stages to put you in orbit around Mars and to bring you back to the Earth. And then of course the big thing is the lander, a Mars lander. And if you'd asked me 3 years ago, I probably would have said that's really the tall pole. We just don't know how to build a lander to land people on Mars. Since then we've done a lot of work, and now I actually don't feel that's the biggest problem. I think the biggest problem is actually life support for the crew for 2.5 or 3 year missions to Mars. And so the deep space habitat, I think, is really the tall tent pole, and NASA is addressing that right now.
So getting to Mars and even landing on Mars, you're saying aren't necessarily the big factors here. We're looking at more of this keeping people alive is the big problem here.
To me right now, I think that is the key technology.
Okay.
Can I ask a question? Sorry, Hoppy, but is this because you think we have mature technology enough so that right now the things we have to do are still keeping the crews comfortable, so to speak, and what we can do the rest, or what has changed your mind over the last few years?
I think we've made a lot of advances in ion drive, solar electric propulsion, and so we feel better about that technology, that's not going to be a problem to develop that. There's been progress made in large solar arrays. I mean, if you'd asked me 5 or 6 years ago, I would have said, well, we'd have a hard time building solar arrays that big. And now there are 3 different industry contractors I know of that have designs that could work for this. And then for the lander, SpaceX has done us all a big favor by returning their first stages, and so we now know that supersonic retropropulsion works, and so we can design a lander that's basically just heat shield and rockets. It's pretty simple. You don't have to have parachutes, airbags. Deployable decelerators could be beneficial, but you actually don't need to have them. So if we wanted to let out a contract to industry to design a human Mars lander in the next few years, I'm actually confident that they will be able to do that.
Fantastic.
Oh, well, I heard you mention things like ion drives and stuff, but that's not really what's being developed right now. The SLS, for example, the main program that's going to be for getting us to Mars, or the main booster rocket, that's technology that's pretty, I guess, tried and true. We've been using it since the 70s, right? Isn't that what NASA's kind of putting all their eggs in?
Yeah, Tony, I'll jump on that one.
Okay.
I think Hoppy's absolutely right about the steps, and really when you look at it, what we had to do when we stopped flying the shuttle was we had to retool because we're going deeper into space. And so for 25 years or so, we were flying up and back to low Earth orbit. We had a lot of good technology there, like you mentioned, the RS-25 engines that were used as the main engines on the orbiter. Those are going to fly on the core stage of SLS, and we're reusing that technology. In fact, we're actually reusing engines that flew on the shuttle for the first 4 missions. Those are not new engines. Those are engines that we're putting a new controller on so that they'll work with that vehicle. But they're tried and true and actually veteran engines that have flown in space. We're going to take and look at new technologies where it's appropriate. And as Hoppy said, we've taken advantage of development that's been going on for years for the commercial satellite industry and electric propulsion, and we're scaling it up to make a cargo vehicle. So we'll be flying at higher power than we've ever flown at, and Hoppy alluded to the array technology. But in terms of the solar electric, it's a scale-up problem. It's an engineering problem. And that's really important because while the SLS gets us off of Earth and we've got Orion to get the crew safely up and down, we're going to need that deep space hab to keep them comfortable, as you said, while they're on their way. These are much longer trips than we've ever gone on before, even in Apollo. And that's why that's such the life support, as Hoppy said, is such an important thing. But the solar electric comes in because you've got a ratio of, something like 100 to 1 in terms of the mass you've got to take out from just the people and all the stuff they're going to need. And we're going to use the solar electric to haul all that stuff out and pre-position it before we actually launch the crew. And that's part of the whole, idea behind, as Harley said earlier, this notion of affordability. We're looking at it a totally different way now. We're looking at it as a logistics problem.
Okay, well,
that's great.
Let's not forget what we're doing now, and Hoppy and Joe pointed out propulsion, in-space propulsion, and then surface-to-orbit propulsion. But NASA is focusing a huge amount of work on the International Space Station to develop environmental control life support systems on the space station that would be applied, or are early versions of that which would be applied to a deep space hab. We are, by the way, going to, in this series, probably the first Friday in August, we'll probably have a couple of folks who are working on the space station, developing those capabilities for very long duration, 2.5, 3 year missions to space. So so the space station is an absolutely essential step on the way to Mars.
okay, well, so you're talking about these technologies, these electric, solar electric propulsion, ion drives, things like that. But are you guys confident in the schedule of how these things are working out? Now, I learned in the Humans to Mars Summit when I was watching the talks that there really isn't a plan for NASA to get to Mars beyond like 2021. Now, you guys work on this stuff all the time. Are you confident that the plan that's currently laid out by NASA and the steps that we're taking to get there are going to, and at what point do these other issues these other technologies get introduced? Because really all I've heard about is SLS, and as Harley said, the space station, but then things get kind of nebulous. How confident are you about this plan, first of all?
Yeah, so there's a difference between the approved plan and what's in the budget that NASA can talk about, and what people are working on in terms of the longer range things. But there are things going on. Hoppy mentioned the solar array development contracts. Those are done. Those, the large solar array deployment technology has been proven. We just were awarded a contract to develop 15 kilowatt Hall thrusters that are going to be the engines that fly on these solar electric vehicles. We're underway. We're kicked off, and we're actually developing that now. So you'll see over the next couple of years a lot more news about that. And then we just have to integrate it into a vehicle. But it's not like something we don't know how to do. And we know it works because Dawn just proved it, magnificently in going from Vesta to Ceres and now hopefully onto a third object. So, it's not like we don't understand how to fly these things.
Right. And even Juno going to Jupiter just this weekend is using a lot of solar. Okay, there's an echo.
Yeah, someone is watching.
Hello, testing. Okay. We're just going to mute all see when it goes away. Okay, testing. Okay, now each of you have to unmute yourself when you go to talk, and then if we hear the echo, we'll hear it again. But one of you is it's got an echo in your system there. So okay, so what I was saying was about Juno and getting to Jupiter. Certainly some of the technologies that were involved in getting the solar arrays, the solar panels to work is really very efficiently, very far away from the sun is being deployed right now, because it's the first interplanetary mission that goes that far out that's got solar arrays on it. So that's pretty impressive, and I know that technology is done, and we're pretty much testing it. But I'm going back to what I learned at the Humans to Mars Summit, which was, I think it was, I read from, was it Feroz Nadiri? He's the director of the JPL Solar System Exploration Directorate. He was saying something about, we need to get to Mars in using the simplest possible architecture. And I guess what I guess that's a segue to is, Hoppy, I'd like you to tell us a little bit about while we're talking about this timeline of getting to Mars, you have developed a plan, or your team and the people you're working with have developed a plan to get to Mars using Phobos, or by getting to Phobos first, I think in 2033, and then followed by a landing a little bit later on in 2039. Can you comment a little bit about those plans?
Sure. So we were looking for an example of a plan that would be implementable, and so we would be able to cost it to see that it would fit within NASA's budget adjusted for inflation, to see, will this really close? Can you really do this and send it to Phobos by 2033? And so we just outlined an example of a plan. It's actually very similar to NASA's split architecture plan, but it's a little bit lower tech. So a lot of the plans that people have for going to Mars use a lot of fancy stuff like cryogenic propellants, in situ resource utilization to make your own propellants on Mars, really high-powered SEP. And so we were looking at trying to, well, what are the things that you really need to do to get there, and don't do anything more than that? Don't do any of the fancy stuff if you don't need the fancy stuff. And so if you bring back up that cost chart there that you had, that line, so we looked at an example program that would send people to Phobos in 2033, and then have a landing on Mars in 2037, and then that would be a short stay mission, similar in scope to like Apollo 17, and then long stay missions after that. And the reason why these things are phased in is because we're trying to fit in a budget line, and so you have to wait until you have enough money to develop the lander. You have to wait until you have enough money to develop the habitat on the surface and the pressurized rovers and other exploration vehicles. But we tried to phase the thing to fit within NASA's budget, and so that's how we came out with this example of a timeline and these costs. So I actually don't see that chart now. Is that chart being
so yes, I've got it
as the main window? There we go.
That you have up. So if you click on it, it'll be large for you as well.
Okay, so there we go. Yeah, so you can see this is predicated on the ISS being phased out, the funding phasing out in 2024, and right now that is currently what's on the books. And so you can see that when the ISS funding phases down, it opens up a funding wedge, and so you can see those different strata of things. The green sand layer in there is a lunar task. And now I'm getting some echo. Let me go back to here.
Okay.
Okay. And you can see that the sort of a salmon-colored is the Phobos long stay mission, and then all that maroon stuff is going to the surface of Mars. And so we've tried to fit that underneath NASA's budget, adjusted for inflation, and at least for this example, it seemed to fit. It didn't require trillions of dollars to send people to Mars. It's being done basically over a period of about 20 years for a similar cost to the space station, around $100 billion. The space station was $100 billion over 20 years, and in this example of a Mars program, it's about the same level of commitment. So it doesn't sound too scary or undoable. It's just a matter
Hoppy, so
let
me just cut in here and ask you something that I want to make sure I'm understanding. At the current level NASA has, and if they implement the plan that you're outlining with going to Phobos, then there is money to get to Phobos by 2033, assuming that NASA gets money that goes along with inflation. That's that dotted line there, right?
That is correct.
If it doesn't get anything more, it's that flat line at the bottom, and none of this.
Yeah, that's bad news then.
Yeah, none of this is doable then. Okay. So is this what NASA is saying they're going? Are they going to go this way? Is the Phobos landing something that they're leaning toward, or is it something that you're proposing, you're pitching? What's the status of this? How likely is this slide to happen?
NASA's planning timeline is to send humans to Phobos in 2033.
Okay.
Now, the vehicles that would do that, and the level of technology used in those vehicles and exactly how they would be deployed, there are still several options on the table for that, and so they've not committed to a particular option. And so what I'm showing here is just an example of an option that seems to work. I'm not saying that that's the way that NASA should go or will go, but it's kind of an existence proof.
Yeah, and I'd just add to that, Tony, that there's a number of us out in industry as well that are looking at these architectures along the lines of what Hoppy's shown. We were thrilled when JPL did this a couple of years ago, or I guess it's only been a little over a year, because it was an existence proof that showed with just the minimal amount of adjustment for inflation, no new budget, you could do it. And you do it in the time frame. That's the other thing. It's not just doing it. It's doing it in the time frame of interest.
Right. And so this...
Sorry, I was going to ask, is this predicated on the 2024 decommissioning, if you will, of the station? I mean, because there were people talking, for example, in 28.
I think you guys showed 2028, didn't you, Hoppy, originally?
Yeah, so we also have a C chart for 2028,
okay.
and it shows that it's also doable, but the sand chart does go a little bit above that line.
That inflation line. I see.
It's not a really scary amount, but it's probably like an extra $1 billion a year that you need, you know, if you keep the space station going. And so we're not actually saying that you would necessarily decommission the space station. It's just that you would ramp down NASA's funding. And people have myriad ideas for what to do with the space station rather than just sending it in the ocean. You know, people talk about pulling their modules out of the space station and building their own space station. There are commercial interests that want to send up their own modules. I think it's plausible that a commercial entity or entities could take over the operation of the space station and relieve NASA and the taxpayers of that burden.
But I guess what I'm getting at is that you're looking for that wedge, basically, that opens up from the station, basically, right?
Yes.
Yes.
Yeah, it was the same with the shuttle. I mean, it's always that way. It's basically a zero-sum game in a lot of ways.
But it's the same in astrophysics as well, right? For, you know,
right.
Now it's going down. Absolutely, absolutely.
Okay, so you want to just to go into the plan just a little bit more. The notes that I took about it shows that there's going to be 4 SLS launches spread out over several years, and there will be the first would be a tug that's propelled by solar electric propulsion. I know you mentioned it before, but what is solar electric? Is it something that you're going to be able to launch from Earth on this stuff, or what is it?
Okay,
Joe, do you want to take this, or do you want me to take that?
Well, let me start. Let me jump in.
There's an echo again.
Yeah, Harley, can you? There you go.
There we go. So I think the idea is, if you think about electric propulsion, I'll just use an analogy to what's going on right now in the commercial industry. You probably heard that Boeing has recently introduced all-electric spacecraft. And what they did when they did that is they were able to get all that propellant that they normally use to go from GTO to GEO off the spacecraft and replace it with a tiny amount of xenon. And we're doing the same thing here with the cargo. So we'll launch mostly cargo on an SLS with a SEP tug that, you know, comparatively takes almost no propellant to get out to Mars. Now it takes longer. It's not a fast transfer, and that's why it goes first. So it'll take a couple of years to 3 years or so, depending on the power level, to get out to Mars. But it'll transfer, relatively speaking, a huge amount of cargo out there, and that can be done in that launch. And essentially, saving launches that are required to get that amount of cargo out there.
So the SLS launch is a conventional launch using conventional rockets to get out into space, and then these electric propulsion drives, solar electric propulsion drives, take over.
And there's various jumping off points. That's the other key thing to know. And people are still studying, as we do these architecture studies, exactly the orbit that the SLS will insert the solar electric tug into. But likely it'll be a highly elliptical orbit around the Earth before it starts.
So give us something to compare it with. With a conventional rocket launch, it takes what, 9 months to get to Mars on a good trajectory if you plan everything right. And so how long are we talking here with these solar electric propulsion?
It's something like 2 years.
Following the same path that a rocket would follow?
Yeah, for the example that we looked at in the JPL study, we were actually looking at sending 40 tons out to Mars orbit with a single SLS launch. And so to do that actually took about 3.5 years. So there's different strategies of doing it. You can start from a high elliptical Earth orbit. What we did is we looked at sending it just almost to Earth escape and doing a lunar flyby and then going out there in 3.5 years. And we could actually get 40 tons out to Mars orbit with electric propulsion. And to put this into perspective, if you're going to send this cargo like a resupply module or the chemical stages to return to Earth, I mean, it would be like 100 tons of LOX hydrogen to send this off to Mars.
Right.
Instead of that, we're using 10 tons of xenon, and so that's a whole lot easier problem. You know, people talk about, well, there's so much LOX hydrogen you need, maybe we need to mine it on the moon or something like that, or launch it from Earth. By using electric propulsion, all you need is 10 tons of xenon, and you know, if you were going to refuel one of these vehicles, you just needed 10 tons of xenon to refuel it. I mean, you can easily do that with a Falcon Heavy launch, so it isn't going to cost that much. So to me, the electric propulsion, the ion drive, is a real game changer, and that's really influenced these new architectures that we've seen in the last 2 or 3 years.
Okay, we're starting to get into the how of our discussion here, and I'm gonna go into this in a little bit more. I just want to finish up with the when. We're still looking. So based on everything you guys have said, NASA's plan, such that it's pretty defined until 2021, but then it gets a little bit not so much after that. We're looking at the mid-2030s, and if we do Phobos, well, okay. Are we doing Phobos? Is that what NASA is looking at doing, Hoppy? Are they looking at doing your plan of getting to Phobos first?
They are looking at the plan of getting to Phobos first, but it's necessarily the exact implementation architecture that I've described. They're looking at several different options, and I think the minimal architecture is one of them. Okay,
good. So I'm going to pull up the slides you brought now, and we'll talk about the how, because there's a lot of different proposals out there. There's a lot of different people that say they can get us to Mars, and so but along the lines of getting us into the NASA timeline, Hoppy, you've given me some slides here that outline some of the architecture that you call it the minimal architecture. So let me share this, and then maybe you can talk about it a little bit.
Sure.
Okay. So here it is. Here's the minimal architecture that you have.
Right. So this is looking after the Phobos mission, the first landing on Mars. And so in this example, this would be done with 6 SLS launches, and those launchers are spaced out over a period of about 4.5 years. So you're really only launching you're not launching any more than 2 SLSs per year, which is really not very daunting. You know, you would think that we would be launching the SLS a couple of times a year. The programs, so that's not particularly scary. And the first 2 launches there.
These here, launch 1 and 2. I hope.
Launch 1 and 2 are these Tugs, the ion drive vehicle. So that's sending some rocket propulsion stages out to Mars to pre-position them, and also a logistics resupply. You're going to need to send more food and air and water for the crew. And the second 2 launches there are the lander. And so launch number 3 sends this lander up into a very higher orbit. Launch number 4, which take place some months later, rendezvous and docks with that lander, and then uses the remaining propellant in the upper stage of the SLS to send that lander off to Mars. And then it'll use the heat shield on the lander to aerobrake into Mars orbit, so it'll await the crew that comes later. And then the crew would go to Mars in launches 5 and 6. So launch number 5 sends this Mars orbit insertion stage and the habitat that they're going to live in to a high Earth orbit. And the last launch, number 6, actually sends the crew up, and so they would dock with this pre-positioned transhab in high Earth orbit, and then use the remaining propellant in the SS upper stage, it's called the EUS, the exploration upper stage, to send the crew off to Mars, and then they would meet up with all this stuff in Mars orbit and do the missions. If you go to the next chart, that kind of shows the departure configuration for the crew using the EUS to leave Earth orbit, and then you get rid of the EUS, and the figure on the right shows the vehicle on the way to Mars. And then it would use that stage on the right-hand side to get it orbit around Mars.
Here, what's that? That's just shoving it out? That's pushing it out there?
Yeah, the exploration upper stage, which is the upper stage of the SLS, actually using that as the Earth departure stage, so we didn't have to develop a new stage to send the people off Mars. We're actually using part of the SLS to do that.
Okay, so
and that's just That's just a high energy upper stage, Tony. It's basically
That's
like
right.
an upgrade to the Centaur.
Are you guys building these rockets? Are you guys doing this?
Yeah. Right now, those are baselined as RL-10s, which are the same engines. It's the upgraded RL-10, but it's the RL-10 derivative, just like what's been flying on Centaur.
Okay.
Yeah, so the EUS has 4 of those.
4, that's right,
Yeah.
instead of 2 on a Centaur.
Right.
Yeah. So we're talking about
if you
these
go to
launches
the
here.
next chart, if you go to the next chart, yeah, so these are the ion drive tugs taking the stages out to Mars and taking the logistics resupply, and they can take their time to get there, and they'll be waiting there for the crew when they arrive. And you can go to the next chart.
Whee!
And so this shows the landing. So in Mars orbit, the crew would transfer to the lander, and they would take that to the surface, land on Mars. There's kind of a depiction of what the lander might look like. And then when they're done with their surface mission, they would take the Mars Ascent Vehicle, or the MAV. And you all saw the MAV in the movie The Martian. That was kind of a big thing, getting to the MAV, but
Exactly.
it's right there with them. So they take off, and the MAV just gets them to low Mars orbit in this example, and they meet up with the boost stage, and then that takes them to high Mars orbit, where they meet up with all the rest of their supplies and their transhab and high Mars orbit.
Okay.
And then if
And
you go to the next chart.
Hopefully we'll do our job
HMO is
better.
not your insurance company. That's High Mars Orbit. Okay.
Right, that's
So here we
right.
got-
High Mars orbit is
Okay.
HMO.
Yeah.
And so this is the concept for entry, descent, and landing, and it's pretty simple. It's just heat shield and rocket. So you enter, you use a heat shield. It's 10 meters in diameter, so it's big. And you do hypersonic aero maneuvering, just like the Mars Science Laboratory did. We jettison the back shell, fire rocket engines, jettison the heat shield, and we have pretty high thrust rocket engines to slow us down. And then as a powered descent, we throttle down the engines and touch down on the surface. And one of the key aspects of this example architecture we have here is that this is a fully fueled MAV, so that at any time during EDL, if there's a problem like one of the rocket engines fail or there's some other issue, that there is a capability to punch out and abort to orbit.
Okay.
And another feature is that if you happen to land off course somewhere and you weren't near other infrastructure on Mars, you would still be able to take off and get the crew back up into orbit again. So that's kind of a safety feature of this particular example design here.
So go ahead, Alberto.
No, I was just, I thought this is actually very very good. I just wanted to recap in my mind to see if I get it right. So basically, I think Joe said this before. So basically, we're trying to set an outpost, so to speak, on Mars, and it becomes a kind of a logistic problem, right? How do we get our stuff there, before we actually get the humans there, right? And so the question I had actually, you mentioned before about solid electric propulsion and xenon, and I heard somewhere that we can actually use other propellant, for example, because xenon is in short supply, I suppose, right?
It actually isn't. Not for the kinds of quantities that we need. Xenon, at the rates we would need it for the Mars mission, is extremely plentiful. And we've worked with all the air liquefaction suppliers, and they assure us that there's no real problem keeping up with the supply. If we wanted to, we could go to krypton or krypton-xenon blends, and those work fine in the thrusters. But there's really no need to for these, unless we went to much more ambitious missions in the future, where we were taking, much more quantity of stuff out there. But for these first 20 years or so of these missions, we'd be fine.
Okay.
All right. So Astro Eustace, I do see your tweet, and I will get to it because you're raising a question I want to get to in just a little bit on Twitter. But before I do that, Hoppy and Joe, these things here that I'm looking at, these seem a little bit. These are looking quite cartoony right now, and I was wondering about they're beautiful, and I'm glad they're here, but I want to ask now about building this stuff. Is this stuff happening, or is these still in the concept pages? I mean, here there's a little footnote that says pre-decisional for discussion purposes only, and so I just want to know, are we getting serious about building these things, or what kind of decisions have to be made before we go from being a cartoon to being something a little more realistic or real?
As Joe mentioned, the piece parts for the SEP tug are being developed right now. And so the ARM mission, one of its prime purposes is to put together the system. So to actually build a SEPTUG and send it on a mission and basically prove out the system design of a tug that's not quite of this scale, but is a significant step to building a tug of this scale, such that we would feel confident on letting out a contract to industry to say, hey, go build us the SEPTUG that we need to send humans to Mars, and that it wouldn't be a higher risk thing.
Okay. And Joe, now I want to go back from something that some of these concepts that are being developed, as Hoppy says, but that go back to the area I think that you're most involved in, which is the SLS, as well as the some of the boosters that are being put on the various vehicles that are going to take us to Mars. The SLS is the. Can you give us some idea, first of all, of what kind of work you guys are doing to build it, and what role you're playing, as well as how are things going on the SLS? What's the next big thing for the SLS?
Sure. I'll try to take them in order and remember everything.
Well, okay, let's just start with.
Yeah, that's okay.
I know. I got
start with what we're doing.
SLS and what you guys are doing.
Sure. We are part of the contractor team, and there's basically four of us. Some people refer to as the four amigos. It's ourselves, Aerojet Rocketdyne, Orbital ATK, who do the solid rocket boosters for the in our. I should have stopped when I said our name. We do primarily the liquid rocket parts. There's one exception to that. I'll get to it in a minute. Orbital ATK does the big solid rocket boosters that get SLS off the ground.
The ones we were talking about earlier that were tried and tested on the space shuttle.
Tested last Tuesday out there.
That's right. We just had a big test.
Yeah, very successful test. Mm-hmm. And then Boeing is the stage integrator for the core of SLS and for the SLS vehicle. And then Lockheed Martin is the fourth amigo, and they're obviously the prime contractor for the Orion crew vehicle. We do a lot of the propulsion for Orion as well. We have thrusters on the European service module, and that's the other thing I was going to bring up earlier when you were talking about cost is we shouldn't just think of this as money that we're going to spend in the NASA budget. There will be international partners for this Mars mission as well, and we already have that with the service module, which is being built over there right now by ESA. We do still the thrusters for them because those are, again, heritage devices, as you brought up earlier. Some of those, in fact, the main engine has its heritage back to the OMS engine on the shuttle. And then we do a lot of the little thrusters that are on the vehicle itself to steer it as it comes through reentry, as well as the jettison module, which takes the escape tower off. So that's kind of a quick snapshot of that. Mm-hmm. But where things are, this is the exciting part. Where they are is hardware is being built. We already flew Orion. We had a very successful EFT-1 test in 2014.
That was a cool
December. Yeah. And, I mean, somebody said, I love this quote. It might have been Keith Cowing. I hate to, if the tribute did wrong, but somebody said, they need to spill a cup of coffee on the keyboard. This is going way too smooth. It's like, by the numbers.
Well, because Keith didn't have any news to report.
Yeah, exactly, right. But that test was very successful. We're gearing up now on SLS. There's a whole lot of hardware being built down in Michoud in Louisiana. We're doing tons of engine tests. The QM2 test was out in Promontory. We test our first stage engines in Mississippi at the Stennis Space Center. And if you get a chance in August, we're going to have a big group outing. I think it's a NASA social, as well as a lot of press are being invited to come down for that test in August, which is always fun. August in Mississippi, you can just imagine.
Yeah. I'll be in Florida then, so I may actually try and go over there.
You should come over. You should really come over. But the real cool one is going to be next year in 2017. We're going to put 4 of those things together under the first stage. They're finishing off the test stand now. It'll be the first time since the Saturn rocket that we've tested a huge liquid stage like that with all 4 engines firing, and it will make the ground shake. I guarantee you.
Wow. Bring back the Apollo days, I guess, too.
Yeah.
Okay. Well, I want to now move on to Astro Justice's tweet, where she is tweeting at us and saying, "What is what is different with Lockheed Martin's 2028 Mars orbit plan, the SpaceX plan, and NASA? And I want to just kind of inject. And so that's the next kind of area I want to touch on with this Hangout. Other people are trying to get to Mars. We've talked about what NASA's been doing. We see what the SLS is doing. What are your comments and thoughts about what other people are doing, other companies? I don't know what Lockheed Martin is doing, so maybe if you guys can comment on that, that would be great. But definitely SpaceX and those guys. What are your thoughts on that?
I can go ahead and speak a little bit about SpaceX. I'm really looking forward to SpaceX, sort of coming out with their plan for exploring Mars in September, and that's when they're going to talk about their architecture. But I think that the Red Dragon, which they've announced that they are going to attempt to launch in 2018 and again in 2020, is a great step forward. And so they would basically be proving out this technique for landing with these kind of ballistic coefficients and entry flight path angles, and basically using heat shield and rockets to land on Mars without a lot of fancy stuff. And if they do that, I think that goes a long way to validating a larger lander to actually be able to land people on Mars and have an ascent vehicle for them to take off from the surface again, and also to land habitats and pressurized rovers and the other infrastructure that we would want to, over time, build up a base on the surface of Mars.
Now, are they still, so they still haven't, I mean, Elon Musk has said he's going to Mars right away, or at least very soon, but they haven't laid out their exact plan yet. Is that what I'm hearing?
He's indicated that he will lay out that plan at a conference in September. So I'm looking forward to seeing that.
Yeah, absolutely.
So do we have an idea, on top of the thrusters that he's developing for his landing on the barge, or what other kind of aeronautics research is needed to allow these large masses to get to the surface of Mars?
Well, if you're talking about the Red Dragon, that's just using the existing Super Draco engine. So it's really not a large modification of the Crew Dragon version that they have planned to eventually land on the ground, on the surface of the Earth, using the same kind of engine. So they already have all that equipment developed.
Okay.
Yeah, I guess the only thing that I wonder is that's good for getting down something the size of the Dragon and some minimal payload that goes with it, but there is that matter of all the stuff that I brought up earlier, and that's why we've taken the steps that we've taken to go to, we didn't just decide we wanted to do solar electric cargo tugs. We had to do that in order to make it affordable to get all that stuff out there. So that's the part I'm anxious to see, as Hoppy says. I'd like to see what their plan is for getting, it's not just getting people out there, it's getting all, think about it, a 500-day mission on the surface of Mars compared to 14 days on the surface of the Moon is going to take a lot more consumables just to keep people alive.
That's what I was asking. So you have a lot more mass you have to move, right?
Exactly.
Right.
That's why I said it's a logistics problem.
Yep.
Well, so I want to go back to a related, since we're talking about other companies, other efforts. I was watching the Humans to Mars Summit, and I saw Buzz Aldrin's talk, and he's proposing this way of getting to Mars called the cyclical approach, and basically he wants to put these rockets or these vehicles in perpetual orbit, or going back and forth between Earth and Mars continually, and I guess we attach stuff to them, or it seems to me like a pretty smart way to go. What do you guys think of that approach? What Buzz Aldrin is proposing, his cyclical way of getting to Mars?
Well, I've always been a fan of Buzz's cyclers. It requires more vehicles. It's a more expensive system. It's designed to be sort of like the Intercontinental Railway to go to Mars, and I think eventually we will evolve to that. But in the approach that we've outlined in the minimal architecture, it's more like sending out a continuing series of Conestoga wagons to do the initial exploration, and eventually, when we decide we want to do things on a bigger scale, I think it's time to go to the Intercontinental Railway and build Buzz's cyclers. It's interesting, if you look at Buzz's book, Mission to Mars, and you look at the color pages in there, you'll see this a couple of configurations. One is an interplanetary vehicle to send people out into interplanetary space. It looks very much like the vehicle that was in my presentation that has a deep space hab and a propulsion stage and an Orion. And if you look at his cycler in there, if you just took the different vehicle elements that were in the presentation I showed, which is a Tug, a Deep Space Hab, and Orion, you could use those elements to build up one of his cyclers. And so I think this would be on a path to eventually evolve to be able to do what Buzz is proposing. It's just that we wouldn't be proposing to do that from day one because I don't think we have the budget to do it.
Yeah, and I was going to just second that. I think in terms of generations of systems, and our first generation systems are going to be relatively austere, and it's because the problem isn't I'll say something that Robert Zubrin says all the time. The problem isn't the technology. We've got the technology. It's the political will, and the only way we get the political will is by convincing people we can afford it.
I know. I need to get
here.
Harley to get some politicians on here so we can really grill them on this, because I've been wondering the same kinds of questions myself. Is just when are we going to get the political will to make this happen? But
we can do that. What do you want?
If you guys are interested, go to Buzz Aldrin's site and learn more about the cyclers. It's called buzzaldrin.com, and then if you go to his website, you can learn more about it. It's a really cool plan, and like Hoppy says, this is sort of more of a what'd you call it? A railway system or something to getting us.
Yeah. I like to use the analogy of when people first came out to California, they came out in Conestoga wagons, and eventually, when there was the business case for it, they built the Intercontinental Railway. But we didn't start off saying, "Oh, we want to settle California. Let's build the Intercontinental Railroad, and we can start sending people out there." I think you want to have the wagon before you build the railway.
Yeah.
Right. Or more importantly, they didn't say we want to go to California, but we've got to wait until we build the Intercontinental Railway to go.
Yeah,
that's
right.
A good analogy. All right.
That's not the way to do it.
Fair enough.
Yeah,
fair enough.
Yeah, and Columbus didn't wait to come to America until we were ready to colonize it, and that came quite a bit later. So, you want to do these things in a stepwise fashion that's affordable, and you can get the taxpayer to buy into expanding the funds that are required.
Well,
I think the key thing is that you want to demonstrate that you can do it before you need to do it a lot.
Right.
Yep.
Yes, that's good. Okay, so Harley, before I get to a tweet from George Caldwell, I want to ask you, Hoppy, you gave us a lot of diagrams and some cartoons for us to look at today, but there's more detailed information on websites. Can you point us to where people can go to maybe learn a little bit more about what you're doing?
So there's a number of papers that we've put out on the architecture, and they are available for free from the JPL Technical Report Server. So that's the URL is trs-new.jpl.nasa.gov, and so you can do an author search and search for Price, H. Price, or Hoppy Price. And you should be able to find the papers. And the chart package that we showed today, I'm going to have that put on the technical report server, but it'll probably be a couple of weeks before that's there.
trs-new.jpl.nasa.gov?
Yeah, trs-new.jpl.nasa.gov, and
all right,
those are all the technical papers you can get from JPL.
I'll put that link in the description too for later, so you guys can check it out. Okay, thanks, Hoppy.
Sure.
All right, so I have a tweet from George Caldwell. He is asking. Oh, you got two of them here. Are gamma ray bursts possible issues when getting to Mars, or is ionizing radiation from the sun the main threat? Are you worried about gamma ray bursts?
I think this is a good time to plug Harley's FISO call that's coming up.
Okay, go ahead, Harley. Why don't we? So, for those of you who don't know, Harley has a weekly Future in Space Operations telecon. Now, it's a little bit. It's not really geared towards the general public so much as it is towards professional colleagues and things like that. But it is something that happens every Wednesday, and I'm trying to turn it into a product that I can put into maybe in a podcast form or something. But in the meantime, Harley does do this every week, and I guess he's got something relevant to that coming up, right, Harley?
Yeah, we do. We have some of the experts on interplanetary radiation, which has been thought to be, probably still is, a major challenge for human spaceflight, a long-duration human spaceflight. So in our upcoming FISO telecons, we'll be having those folks speak to new results that suggest that radiation is always something you've got to be wary of, but seems to be not as dangerous, not as limiting to long-duration human spaceflight as was once thought. For folks who follow us on this Hangout, we're going to have those folks in a few weeks or so, not exactly sure when. So the folks who follow us Hangout can just stand by. They'll be on here soon.
Yeah,
so Harley, one of the things that you might point out is even if you aren't on the invite list to be able to attend the FISO in real time, all the past FISO presentations are available in an archive. Anybody can listen to any of them.
Yep, exactly right.
Okay, so I have an email question here.
Oh, I was going to finish George's. Give him an answer. I'm sorry, we sort of tripped around that one, but the bottom line is on the radiation side. That's obviously one of the reasons we got to go out beyond the Van Allen belts, go out around the moon and test some of these systems out. But it doesn't look like a showstopper.
Okay, and are you more worried about gamma ray bursts or just the solar radiation in general?
I think it's just basically galactic cosmic radiation. That's the big issue.
Okay.
And the other thing, I don't know if gamma ray bursts are as the occurrence is as common as you think. In terms, they are very energetic or very beamed, right? So I think if you look it up, they occur like maybe one a day, but it has to be energetic enough to do damage, right? So it's unclear now if that's actually the case, unless it's very, very close, right? So the closest one was 40 million parsecs away. So
yeah.
Okay, so there's a little thing in my chat box to give the Humans to Mars website. Harley, why don't you give that out to people, the Humans to Mars website?
Tony's been mentioned a couple of times, as we have in previous Hangouts, the Humans to Mars Summit, which was, what was it, this past May? A bunch of us were there. I'm already forgetting. It happens every late spring. And folks, if they want to see it where most of the presentations are video archived, look up, just do a search, use your search engine to find Explore Mars Incorporated. Explore Mars Incorporated. And within the Explore Mars Incorporated site, you will find their Humans to Mars archived videos. Well worth, trivial to find, and well worth it.
Oh yeah, and I watched a lot of those live streamed, and they're still archived. They're outstanding talks. Okay, we're getting a lot of tweets, so I need to move along here. Astro Eustace is also asking a really good question that I'd like your input on. On this development track, the ISRU, that's the Indian Space Resource, I think is it ISRO?
In situ.
Well, okay. ISRU. I thought those I was thinking the India Space Research Organization, but maybe that's not.
That's ISRO.
ISRO, yeah.
Okay.
Yeah.
Well, okay. Then I'll just.
Real close.
Okay? ISRU being seriously discussed as part of the minimal architecture. Sorry, I messed that up. I got my acronyms messed up.
The minimal architecture does not rely on ISRU initially, and ISRU actually is complex and expensive development, and there are some risks associated with that. So in the example of the minimal architecture, the thought is that after a few missions to the surface, and we delivered hardware and cargo missions to the surface, we would start producing propellant on Mars. You'd start producing LOX out of the atmosphere, and you transition from basically a hydrazine nitrogen tetroxide bipropellant system to a hydrazine LOX system, and so that way you would be making your oxidizer on Mars, and you would transition into ISRU for the ascent vehicles. And the first mission to Mars actually would use ISRU to generate supplemental breathing oxygen for the crew. So we would want to do that from day one in this example architecture, because you're only talking about making a few kilograms a day to make supplemental breathing oxygen for the crew to allow them to do more EVAs. So yeah, ISRU would be part of the minimal architecture, but it would be an evolution. It would be something that would be phased in over time as the business case for that developed.
Okay.
Yeah, and I just want to point out that actually it is being thought about a lot. There's going to be an experiment flown on the Mars 2020 lander called MOXIE that will demonstrate what Hoppy was just talking about, making some oxygen at a very small scale. But the consumables, again, the stuff, that's a big deal. So whether we use it for rocket fuel or just for supplemental breathing oxygen, we're also looking at landing sites that might have water resources close by. So yeah, living off the land in the long run is going to become very important.
Exactly.
Yeah, in the long run, there's no question that that's the way to go. But I think the real issue is, do you need to do that first? And that's a gate you have to pass through before you can send people to Mars, or do you want to start sending explorers to Mars and then bootstrapping and building up its capability to live off the land? Because there are a lot of risks and complexities associated with that. It isn't easy.
Right. One of the things you need for really big systems is a lot of power, for instance, and that takes a while to develop that capability on the surface.
And you also have to radiate a lot of heat away to manufacture the stuff and also to store it if you're storing cryogen. So even the heat rejection is a big problem.
Okay, good one. So I have an email question that it's from Maul. He emailed at hangouts@deepastronomy.com, and his question is rather involved. But and I hope I get this right because I couldn't read. I don't want to read the whole thing. But he's asking about using the argument about using retro propulsion, things like rockets to land things on the Mars. Why don't we use more winged approaches, more like paraflyers or paragliders or parawings, I guess is the word he used, and lifting bodies of various types to get us down on safely on Mars? Is there any thinking going along on those lines?
Oh yeah, there's been a lot of research done on these high L/D ratio landers and trying to fly on Mars to do the landing. And the problem is there's just not much atmosphere on Mars, and so it's really hard to build those vehicles. And you know, we really think that the most cost-effective way to send people to the surface right now is using supersonic retropropulsion and not. You know, there are some nice designs for inflatable decelerators which can help the problem, but it still isn't like a winged vehicle where you can go and land like an airplane. It's just too hard to do in such a thin atmosphere. It's interesting that the Mars 2020 rover is actually looking at carrying a tiny drone helicopter, and so that would actually fly in the thin Mars atmosphere. But trying to land large payloads that way just doesn't seem to be in the cards right now.
Okay, good question, Maul. Thank you for asking that.
We should have a hangout at some point to talk about. In Northrop, we're doing something along those lines, so we should talk about that.
Absolutely. Well, yeah, you're doing it. You've got engineers working on this problem already, don't you?
Yeah, we do. But I think Hoppy had the great point is that the atmosphere is so thin that is very, very hard. You know, if you want to go to Venus, you want to go to things like Titan or something, that's very different. The atmosphere is
much easier to fly in a thick atmosphere like that.
Yeah, but I think there are ways for you actually to solve some of the problem. It depends on what kind of mass you want to take to the surface.
Isn't the old saying? I don't know if it's still true. Hoppy would know this. Isn't the old saying about the Mars atmosphere? It's thick enough to cause problems, but not thick enough to offer solutions.
I was just going to say that, Harley.
That's great.
It's the rule.
I'll get this one down.
Okay. Okay, so we're running out of time. I have a couple more tweets I want to get to. Kenneth Roy is asking, how are you planning to tackle the effects of long-term space travel? Anybody want to take that one? I mean, we've all seen the Scott Kelly being up in space for a year and we're studying the effects on that. What do you in the various pipelines or the various plans that we have? How are we taking that into account?
Two-step process. The first step is ISS, and we're continuing, like you said, the Scott Kelly tradition. There's obviously continuing crews going up with various specific things they're looking at, including countermeasures for microgravity. And other fluid issues, in terms of body fluids relocating themselves in the body in microgravity. We got to get outside the Van Allen belts to deal with the radiation problem, so we're going to go out around the moon, and we're going to do the deep space habitat testing out around the moon.
All right, good question, George. Thank you. All right, well, with that, I'm going to go ahead and close out our Hangout because we are out of time. Thank you guys for tweeting and emailing me. This worked out pretty well this time. I'm glad we did it that way. I hope you guys enjoyed our Hangout. And I want to thank our guests. Joe Cassady from Aerojet Rocketdyne, as well as Hoppy Price from JPL. Thank you guys so much for taking time out to talk to us about getting to Mars. This is wonderful stuff. And
Thank you, Tony.
you're welcome. Thank you very much, and go back and have a great vacation, Joe. I'm interrupting you. Okay, so we are, as Harley alluded to, and as I said at the beginning of the Hangout, we do these every month. Next Friday, the first Friday of August, we'll be back. And Harley, do you have a subject for us or a preview?
Got a couple of subjects still in work, so folks keep watching this site.
Preferably number 2.
Yes, we think there'll be a number 2. As I said, very likely we're going to try to get a couple of folks on here to talk about the developments on the space station, specifically for being able to travel to Mars, and a second person on here who will be talking about what is the next step in long-duration habitations after the space station, the stepping stone after the space station to Mars.
Awesome. Okay, well, thank you, Harley. Don't forget, he's got his Future in Space Operations Telecon every Wednesday, happening, I think it's at 3 o'clock. So we check that out if you can. And we will be back in 2 weeks for our Future in Space Hangout, where we will talk about the future of space in general. And so we hope you guys will join us for that as well. Every other week at Deep Astronomy, we got a different hangout for you, and we're actually planning on doing more. So hopefully we'll be doing this every week. So
we'll see much more of Tony.
And always. Maybe good or bad thing, I don't know. Anyway, I want to thank all of you guys for watching. Thanks to both of our guests, and also thank you, Alberto and Harley, for your time. I appreciate it. This has been a great one. Thank you all for watching, and as always, keep looking up.